My name's Bill Pollard. I put my contact information on the board over there. If there's anything I can ever do for you guys, please don't hesitate to contact me. Today we're going to be talking about MST 675, applying temporary safety grounds. Just an agenda for today. We're going to talk about the objectives. We're going to do a little bit of an introduction. Included in that introduction, we're going to have a safety discussion, and we're going to talk about 1OE. I'll present the information, and then after the information is presented, we'll do a summary. Terminal objective. It's really pretty straightforward. At the end of the training, you will be able to install a temporary safety ground on any piece of equipment. We're going to measure your ability to do that by performing 2 JPMs, one on a piece of mobile equipment and one on a plant electrical equipment, maybe a transformer or some bus work or something like that. Specific objectives. Dave, why do you think specific objectives are very important? Why are you interested in specific objectives?
I usually come in with 2 questions. What am I going to be tested on in detail, and where are the donuts?
Exactly, right? And the donuts is probably first, right? But like Dave said, this is where all your test questions, your JPMs, and your evaluation methods come from, is the specific objectives. So if you pay particular attention to these specific objectives, you'll do okay on the JPMs. All right? First thing you're going to have to do is choose the correct voltmeter when we do no voltage checks. All right? We're going to look at a task matrix. And from that task matrix, you're going to have to choose PPE and arc flash clothing to do 2 tasks. That is to perform your no voltage check and to apply your safety grounds. And then you're going to have to obviously know how to install them. There's a specific sequence depending on the equipment that you're installing the ground on. We're going to look at those sequences. Any questions on the objectives? A little bit of an introduction. Some main topics we're going to cover today. We're going to talk about the meaning of the term ground. We're going to talk about the purpose of the temporary safety ground. We're going to talk about how things can become energized even though we have de-energized them and disconnected the electrical power source. We're going to talk about selecting PPE and arc flash clothing. We're going to establish an arc flash boundary. And we're going to talk about all the different kinds of equipment, mobile equipment, plant electrical equipment, and how to apply those grounds. Before next break, I'm really going to concentrate on 2 areas. And I want you guys to stay focused on these 2 areas, because when we do the summary, I'll be asking these questions. Okay? First of all, I'm going to focus on why do we put temporary safety grounds on? All right? And there's actually 2 reasons. So look for those 2 reasons in the training. We're going to talk about how we can keep any piece of equipment at 0 volts. Because we're going to see, even though we may have something de-energized on a clearance order, it could still become energized. Okay? So we're going to see how we keep something at 0 volts. Please always keep in mind all of our safety rules, our policies, safety procedures. For you guys as electricians in the power plants, there's some specific ones if you want to write these down in your notes. Safety rules, Generation Safety Rule Book, Section 8. General safety policies, there's 2 of them that you should be mindful of. GSP 5 talks about grounding and bonding. GSP 51 talks about electrical safety. In the nuclear world, you guys operate according to all kinds of procedures. The Susquehanna safety procedure that you have to be aware of and become intimately familiar with is SP00111. All right? So keep those in mind. Learn them. At least know where to look for information. Another thing we want to talk about throughout all this is the use of human performance tools. I wrote down a couple human performance tools that I felt could be used when we're applying temporary safety grounds. What does first check mean to you, Joe?
Well, that'd be the first time you check the condition of the equipment and see if it's de-energized or needs to be de-energized, that type of thing.
So, and Joe mentioned something very specific there, first check, right? The equipment is de-energized. So even before you want to check the equipment to de-energize, maybe what's one thing you want to check before you do that? Eric?
You want to check that the equipment you're working on is the right equipment.
Is the
You're checking the EPN, and then with where I've come from a first check, when you check the EPN, you identify the equipment, and then you would call your supervisor or the control room and say, hey, I'm working on this, blah, blah, blah.
Exactly, exactly. Questioning attitude, we can use that. You could probably list 100 things. Steve, keeping in mind this job that we're doing, installing temporary safety grounds, where might you use questioning attitude?
Well, if I was to walk up and try to get started in my task or anything and something didn't seem right or didn't feel right about it, I want to make sure before I can continue on that things are actually like they should be. I don't want to just say, oh, it's already being de-energized, I can just work on it.
Okay.
I want to verify. I want to make sure if I have a question in my mind, I want to alleviate that question.
So Steve kind of generalized it, but thinking about putting a safety ground on, what are some specific things we might want to question? Dave, any thoughts?
Well, yeah, I'd always be questioning, am I using the right type of grounding device? Is this a good ground to go to? Am I actually going to live voltage rather than the ground? And actually first check on even on the right equipment in the first place with permission to do the work.
Excellent, excellent. Okay. Next one, peer check. When might you want to use peer check? Doing this task, Dave. Think specifically about hanging this ground on and when you might want to get your buddy to check this.
Well, throughout the whole process, you want to have your peer check you to make sure you're doing it in accordance with the procedure and that everything is the way it should be installed.
Okay, that's good. I think it was Dave that mentioned a couple things, and somebody else, maybe Joe, about being de-energized, right? Maybe a good peer check here would be, hey, Eric, do I really have zero here? Would you check this for me, right? Dave mentioned grounding locations. This Dave. Maybe he wants to ask this Dave, am I really on the right spot here? Okay, so some human performance tools that could be used, right? Could you think of any others?
Human performance tools?
Yes, any other human performance tools pertaining to this task?
STAR, stop active view, is a critical component of peer check just for yourself. Initially,
Right.
your first check and peer check.
Okay.
So how would you start?
Fits
Good.
right in with the 2-minute rule idea also.
2-minute rule. I like that.
Time to check the key thing. We're talking about electricity here.
Yes.
So, right, there's a whole lot of reasons to make sure you take a minute, make sure everything's right. Like on the first check, we've even had people have a peer check, and then they end up making a mistake because peer didn't do a good job checking, and they're on the wrong piece of equipment.
Yes. All right. Joe mentioned something. He said we're working with electricity, and a lot of bad things can happen, right? What's the worst thing do you think that can happen working on this stuff? Eric?
Death.
Death?
Electrocuted.
Electrocuted. Okay, most people when I ask that question say death. I see a little skepticism in Dave's face.
To me, the worst thing is always permanent, scarred, paraplegic. You can't enjoy life, but you've got to suffer.
I agree with Dave. I agree with Dave 100%. Death is permanent. You're gone, right? Let's talk about, this is a good place to talk about our OE. I passed out an operating experience. You can read it later, okay? I'll sum up what it says. And it talks about what Dave said. This, to me, is worst case scenario. We had a fella, journeyman electrician, working from a basket on a line. He had that line de-energized, and he had that line grounded. All right? Now you'll have to use your imagination a little bit, but pretend he's in a bucket. Okay? He's working on that line. The work that he was performing actually broke these grounds. All right? We're going to talk later on about how this happened, right? One of our major topics was how something can become energized because even though it's de-energized, this line was running close to another 500 kV line. And when he broke that second ground, the line he was working on became energized by an induced voltage being in such close proximity to that 500 kV line. When he did that, when he broke this ground, this wants to arc, right? Instead of arcing through the vehicle and back down to ground, it arced through him, right? Lots of pain and suffering, okay? Lost a hand, all right? Life-changing event happened to this fellow. Didn't kill him, right? But he went through a lot of pain and suffering, okay? Affecting him and his family, right? He's not going to be able to live the lifestyle that maybe he lived before, okay? So keep that in mind. Also keep this in mind, right? We're going to cover the information now. I want you to be looking for these specific things. So here we are, or here I am. I used to ask people, what is this? But I got too many different answers. That's PPL Susquehanna Power Plant. All right? And down here is my house. My little door. And on my house, I have an electrical service. All right? Susquehanna down here is doing something. We'll talk about that something in a minute. And providing me with electricity to my house. Joe, what are we doing there at Susquehanna? What are we making?
We're producing electricity.
We're producing electricity. What are a couple of terms you know of with electricity, Dave?
There's kVA, kVAr, I squared R losses.
Let's get a little more basic than that. Voltage and amperage. That's what I was looking for. All right? So we're actually generating a voltage. All right? We're going to have a little electrical theory review because it'll help you to understand the whys in the hows. Okay? We're generating a voltage. I don't have current yet going to my house because this thing's open. Whatever this thing may be. It may be the generator, breaker, or disconnect or something. Right? When I close this, what happens? Now what do I have going to my house?
You have voltage, current flow.
I have current flow now, right? I have current going to my house. Eric, do you know what the definition of current is?
It's the amperage flow. It's the flow of electrons.
Flow of electrons, exactly. That's what I was looking for. Flow of electrons. Those electrons only want to do one thing in their life. Dave, do you know what that is? They only have one thing that they want to do more than anything else.
Find a positive source to go to a lower energy state.
Lower energy state. What's the lowest energy state? in terms of volts?
0 volts.
0 volts.
No change in potential.
What's at 0 volts? What are we talking about today? Ground. Okay? More than anything, these electrons want to go to ground. Just like Dave said. They want to go to lower potential. The lowest potential is ground, which we actually define as being at earth potential or 0 volts. All right? Joe, do those electrons care how they get to ground?
No.
Will they go through Eric?
They'd be glad to.
They would be, right? What will current always try to do? Path of least resistance. So if Eric's the path of least resistance, they're going to go to Eric. All right? So let's say we have a crane. We have Eric driving the crane. We have Dave as the ground hand. Eric runs that crane into that line when it's energized. What's going to happen to those electrons? They're going to go down through the crane, right? We want them to go through the crane. What don't we want them to do? Go through Eric or go through Dave, right? So we're going to help those electrons get to ground. So they don't go through those guys because we like those guys, right? This thing could be some protective device, right? Generator, breaker. Most people can relate to breakers. How does a breaker operate? What does it look at? Amperage, okay? We know from electrical theory that amperage, I equals E over R. E being voltage, R resistance. We're not going to do anything with this, but we're going to do something with this. We're going to lessen this resistance. So what happens here? It goes up. Okay? It goes up so high. We do that because we want this to operate as quick as possible. Right? Under normal conditions, Eric didn't run this crane into these lines. Under normal conditions, what do we want that crane to stay at? How many volts? 0 volts. We want it to stay at 0 volts. So if we use a low resistance cable and connect it to something that's at 0 volts, what happens to this? Russ? It'll stay at 0 volts. Okay? Any questions on any of that? So going back over here, I asked you guys, as kind of a summary to what we talked about, why temporary safety grounds? Steve, give me one answer.
Okay, personnel.
Personnel. That's number one reason. Personnel safety. We like Eric. We like Dave. We want them to come back to work tomorrow. We want to protect them, right? Joe, what's the other reason we mentioned?
Keep that equipment grounded at zero voltage.
That kind of answers this question, right? How something stays at 0 volts. So I'm going to write your answer down, but I'm going to write it down here. And I'm just going to write by grounding. Okay? But what's the other reason why we mentioned there? Dave?
It allows the other equipment, like the breaker or whatever device you have set up to work what you're supposed to work.
Exactly. We want these things to operate as fast as they can. And that, in turn, will actually help our first reason, right? Protect personnel. So we're going to just, right here, help things operate. Okay. Any questions on anything we covered? Anything at all? If not, we'll take a break and pick it up later.